Every day, we use products from organic compounds, from fuels to power our cars, plastics to package our foods, medicines to keep us healthy. But have you ever wondered how these molecules are made, why they work, and what impacts they have on our world? Today, I'll be running you through testosterone, the primary male sex hormone, created both in the body and artificially as a treatment for low testosterone and hypergonadism. Testosterone is 19 carbons and 28 hydrogens and 2 oxygens built off of a 4-ring skeletal chain called an androsten steroid nucleus with 3 cyclohexane rings and 1 cyclopentane ring, including multiple functional groups such as 1 ketone on carbon 3 and a hydroxyl group on carbon 17. Also includes a C4 to C5 double carbon bond, and lastly 2 small methyl groups on positions C10 and C13, all shown in the diagram. The prior knowledge required for this is, first, what is a hormone? A hormone is a compound produced in the body that initiates a physiological response. An enzyme. What is an enzyme? An enzyme is a type of protein that acts as a catalyst in metabolic activity. And what is a steroid and its structure? Right? A steroid is just 3 cyclohexane rings and 1 pentane ring. When in the bloodstream, reacts with SHB, or sex-binding globulin, in a high-affinity, non-covalent bond where SHB carries testosterone around the body until it reaches its desired location. The androgen receptor, where testosterone is exposed to the enzyme 5-alpha reductase that reduces the C4-C5 double bond via NADPHA-dependent hydrogenation, turning the testosterone into DHT. To fit the androgen receptors better due to the change caused by the saturation. It is the male sex hormone produced in the testicles that is largely responsible for the development of male sexual dimorphic characteristics such as increased bone density, muscle mass, and libido. Testosterone production is a sequence of chemical reactions mostly taking place in the testicles. The reaction starts with cholesterol, involving an oxidative cleavage catalyzed by the enzyme CYP11A1 using O2 and NADPHA. As a structural result, the carbon count is reduced from 27 to 21. Pregnenolone, through the use of CYP17A1, performs a hydroxylation on carbon 17 alpha-hydroxypregnenolone using the enzyme CYP17A1 performs a cleavage between C17 and C20, releasing a 2-carbon fragment and structurally removing the side chain beyond C17. This reduces the carbon count from C21 to C19. Losing a part of its side chain, dehydroepiandrosterone is produced, transforming the typical steroid base into an androgen backbone. DHA is subjected to 3-BHSD, where the OH at carbon 3 is oxidized from a hydroxyl to a ketone via hydrogenation. And then the C5-C6 double bond migrates to the C4-C5 to stabilize, and this is called isomerization. This step is crucial because it converts the weak androgen into a much more biologically active state. This new compound is called androsten. Reaction in the chain is between androsten and testosterone, where the enzyme 17-BHSD catalyzes an NADPHA-dependent reduction of the C17 ketone to a secondary alcohol, where the oxygen double bond on carbon 17 is reduced to an OH hydroxyl group, as this process takes place in the testes. For males, past the age of 30, where testosterone starts a downward slope, of approximately 1% per year, causing brain fog, cardiovascular disease, and metabolic problems like high cholesterol, type 2 diabetes, and cardiovascular disease, leading to high mortality rates among mature-aged men. Low testosterone has side effects including loss of sexual function, loss of bone mass and muscle density, loss of erectile function, and increased visceral fat. As a hormone, testosterone suppresses a liver function called hepcidin that is responsible for blocking iron absorption in the blood. When testosterone decreases, the iron in your blood increases, reducing your blood's ability to carry oxygen. Simultaneously, it sends signals to your kidneys to increase production of erythropoietin. This reaction signals to your bone marrow to increase blood supply, leading to your blood thickening. This hinders oxygen transport and increases clotting, leading to the aforementioned risks to the human body. Testosterone is an androgen hormone and is highly potent, classified under the Global Harmonizing System as a dangerous substance requiring handling protocols due to its reproductive toxicity and potential carcinogenicity. The endocrine system is a very intricate system where it is designed for small concentrations to have a massive effect on the body. Testosterone binds the androgen receptors and influences DNA expression, leading to powerful systematic changes on development and metabolism. Due to its fatty lipid base, testosterone can penetrate biological membranes easily, making skin absorption and inhalation possible. When exposed to rivers or lakes, the hormone can act as an endocrine disruptor and negatively affect the animals and possibly human life because of its impact on because it can be impactful in minuscule concentrations. Safety and handling. Access control. Testosterone can only be permitted under a qualified supervised authorization and through the use of PPE like gloves, lab coat, and eye protection, and handling under a fume hood. It is required to prevent skin absorption or inhalation. Storage. Testosterone can only be stored in airtight, light-resistant containers at controlled temperature to prevent degradation. Disposal must occur via a licensed pharmaceutical waste streams, as releasing into waterways can cause endocrine disruption in aquatic organisms. The current solution for low testosterone is testosterone replacement therapy, where testosterone is artificially introduced into the body that in turn signals to the brain to stop natural production of testosterone, leading to many side effects including shrunken testicles and infertility. The body is a complex process, and treating low testosterone with testosterone replacement therapy, or TRT, in lifestyle factors such as sleep resistance training and diet can improve testosterone levels. Clinical hypogonadism often requires testosterone replacement therapy. However, testosterone replacement therapy carries risks including infertility, erythrokeratosis. So treatment should be individualized and medically supervised. Increase in testosterone and fertility in men with low testosterone or hypogonadism. Zinc supplements can be used. Zinc supplements enter the Leydig cells, and in the Leydig cells, zinc reduces oxidative stress through a combination of indirect antioxidant actions, including activating the NRF2 enzyme that produces antioxidant enzymes, and inhibits NFKB that controls inflation and increases cell survival, that leads to increased survival of Leydig cells, naturally increasing testosterone as Leydig cells increase testosterone.